Hello everyone. So in this video, we are going to discuss one another example of Euclid's division algorithm. This example is a bit based on the practical use of the Euclid's division algorithm. So in question, it's given that a sweet seller has 420 Kaju burfis and 130 Badam burfis. Okay, a sweet seller has 420 Kaju burfis and 130 Badam burfis. Okay. And what she wants is that she wants to stack them in such a way that each stack has same number. Each stack has the same number and they take up the least area of the tray. Okay, she wants to stack them in such a way that each stack should have the same number and it will take up the least area of the tray. So for this, we will have to calculate the HCF. Like, let me show that. Think if you have six oranges, okay, six oranges. This is orange color. 1, 2, 'these are 6 oranges, and let's say you have four apples. Okay, so here we'll draw 4 apples. 1, 2, 3, and 4. Now what you have to do is to stack them in such a manner that each stack should have same number of fruit and it will take the least area. So what we'll do is to calculate the HCF. Okay. We will calculate HCF of 4 and 6. We know that HCF and 4 and 6 of 4 and 6 will be 2. Okay, so what we'll do now, we will make stack having 2 fruits in it. So let's see how can we do this. So here the color orange, this is the size. 1. Okay, let me do it there only. Yeah. Yeah, so this is stack 1. This is stack 2. This is stack 3. This is stack 4. This is stack 5. See how easily can we divide them into stacks having equal number of quantities in all of them with taking least area. Like if we will divide in them in the stacks of 3, you will remain with a remainder finally. Like here, let me show you. This will be stack 1, this will be stack 2, this will be stack 3, then you will need another place for this one. Okay, so we'll find HCF of these 2 quantities and then we will divide the stacks having this number of quantity of fruits in them. Okay, so through this we'll solve the example. Yeah, here 420 Kaju burfis and 130 Badam burfis. So we have to calculate the HCF of 420 and 130. HCF of 420 and 130. Then this number will give us the maximum number of burfi in each stack, and the number of stacks will then be the least. Fine. So moving on to the next slide. Here, what were the quantities? Quantities were 420 kaju barfis, 420 kaju barfis, and 130. 130 was 130 was badam barfis. So 130 badam barfis. Here we calculated the HCF of these two numbers using Euclid's divisions algorithm. Okay. So this is how we'll do it. 420 is bigger than 130. So we divided 420 with 130. We got Q as the quotient and 30 as the remainder. Remainder is not equal to 0. Hence we proceed further. We'll divide 130 with 30. Okay, again remainder is not equal to 0. So now 30 will be divided by 10. Here the remainder is 0. So 10 is our answer. If we'll divide the stacks having 10 quantity, if we'll divide the stacks having 10 burfis in each, then it will take least space. It will take least space and will have equal number of burfis in each stack. So this was the problem for today. The sweet seller can make a stack of 10 for both kind of burfis. Now we'll discuss fundamental theorem of arithmetic in the next video. Till then, bye-bye, and practice some of the questions of these. Okay.